Hey, jom. Let's sembang AIoT. Yeah, thank you for watching again. Very good afternoon, good morning, good evening, wherever you are. I'm Cecily here again. Meeting up with you in this live session with Kenyong together.
Kenyong.
Hi. Okay. So this is our 17. This is our 17. Number 17 on the live session number 17. So just a click of eyes, 16 already gone. So number 17. 17 meaning 17 week. We did it weekly. So it's a 17. So welcome to this Let's Among AIoT session again, the live session to you. So I hope you are still following us, and please remember to SSL. Yeah, what is SSL? SSL.
Share, subscribe, and like.
Share, subscribe, and like. So maybe today we want to start off something different today because the past session that we had, we talked about from the very beginning, end to end, machine to machine, we talk to IoT. Of course, we talk about AI, and then we cover several different areas of application of IoT and AI. Yeah. So that was the past, and then also in the middle we have about almost 7 to 8 sessions talking about smart manufacturing, applied application of smart manufacturing in IoT and AI. And then recently also we have quite a number of subscribers. Some of them came from the institute, from college, from university. Yeah. So that's why we discussed, okay, now maybe we will start everything new again, but we talk about those fundamental things that IoT or industrial IoT being used in the different area in the industry, and also what are the data concerns. Yeah. So today I'm going to talk about something related to the very fundamental measurement of IoT sensors. That's why the subtitle is IIoT Sensors to Cloud. Of course, Kenyong will be covering different areas. Maybe he will tell you more after that. Do you have anything, anything?
Okay, so for the IoT, we talk about the sensor. So sensor is the first thing. It's like an input for the entire IoT system. But then for the AI, the input for the AI is the data. So the data coming from where is also coming from maybe from IoT side, or maybe from other system or from other device. So today I will cover more on how to create the data set by using the data.
Yeah. So we are covering very fundamental things, especially those who are new or you have just watched our session. Probably this is a very good beginning start. Yeah. So just a quick chat about the IoT, Internet of Things. What are the day life IoT that you do or we do or company do? Can you that one?
IoT thing. The very first thing is every day when I arrive office,
Okay.
the very first thing I will take out my phone, open the Tesla SCADA apps, and then trigger our fun gate.
Okay. So that is one of the gate control that we apply in our company daily in the morning. We use our mobile apps to open our gate. Even for myself, I slightly spatial. I have some sensor in our room, so we can turn on the air condition, see the temperature and so on. This is one of part of the IoT that we apply. Of course, at the outside world, I mean in the day life, You use a Grab. Grab is also one part of the IoT. Yeah, Grab, very successful kind of application in the real application. Grab is one of them. Of course, inside our company we have another thing, that is on the AI. Yeah. So after entering the gate, Kenyon will go in front to the glass door. There is an AI app, running at the back. Yeah. One of them is a facial recognition, right? So we are in a way practicing the AIoT thing, daily, every day, since maybe about two and a half years ago. Because our this gate control was set up in one of the clubhouse, and then it's battery powered, right? It's battery powered. Let me show you. This is a very initial apps that we use. After that, it evolved in some other thing. Let me show you. This is how it looks like. Yeah, this is how it looks like. Yeah, you can see the temperature of the room temperature, and then you can control gate. You can even open the door, and so on. Yeah. So this is one of the IoT apps. Yeah. So of course, Kenyon has got different set of apps. He is using more advanced one on SCADA to.
My one very simple.
Oh, very simple.
Because I just want to open the gate.
Okay. So that is one of the
my one, just one line.
Oh, just one line.
Just one line. One minute. The gate will open. Just one
Okay.
line.
Okay. Those are battery operated, Those things.
Just one button. On and off.
Yeah. Oh. Wow. It's one of the button. So this one we can easily create ourselves, right?
Yes.
So of course, in between the connectivity in our building also, we have some wireless going on. That's running on a LoRaWAN network. LoRa, not a LoRaWAN, it's a LoRa transceiver, which get of all these what you call the wiring. You don't need to do wiring. You don't need to use wire. You can do it wirelessly. Okay, I think. Actually, I want Kenyon to start off with the thing. Maybe I'll do first.
Okay.
I'll go with this IoT thing first. So in the last week exhibition, is it last week? Yeah, we did the last week exhibition that just came back, and one of the very important thing is about I did the presentation during the day. So can I have a slide? Okay, maybe today we start up something with the second one. Before that. So maybe you would like to ask, what is exactly IoT or AIoT? So my simple definition for you is Internet of Things is something to do with the connectivity. Yeah, when you need to connect, okay, you need to do a connection. Okay, so after connection, what you do, what you get? Yeah, you are going to get any device, any data, and anywhere. So meaning with this connectivity, you are able to connect to any of the device, to you, of course, as a human being, or any kind of data that you want to transfer or exchange between you and the machine, or between you, like on turning on the gate. This is how we connect to our device, and it can be done in anywhere. So I hope that very simple definition of IoT, that is outcome of the whole IoT. But what about AI? What about AI? Okay, so AI, we will have at the back, AI will do a lot of computation. I don't know whether I can agree with me. He hasn't seen this one, the computation, and a lot of simulation. Then what we get? So AI is something that you are able to make use of some of the machine performance or some of the calculation that be able to be done in the processing unit, to give you any data, anytime, and also anywhere. Yeah. So of course, this is very, very, very layman kind of way to define IoT and AI. Yeah. So with these two, as when IoT right now is so matured, you have what happened when the IoT meet up with this AI. That's why we have this AIoT. IoT being very active in the sense that because it's dealing with connectivity. So if you see this symbol, this is not a religion. This is not a religion class. Basically, this symbol is a Chinese old Chinese philosophy. It's basically a yin and yang. It's a Tai Chi. It's a Tai Chi of that describe the yin and yang. So being IoT is one of the part of the yang. It's doing a lot of work. You need to do a lot of connectivity. That's the yang part. But the AI side will do a lot of the processing at the back. So it's doing the yin part. So both of them, when you meet together, you know what will happen? Yeah. So you get a transformer. So when two of them meet up together, you become you get a transformer. Of course, this is it Optimus Prime? I don't know I don't know the name. It's one of the transformer. Then what happened? We're having a transformer. When both of them meet up together, you will have this. We have this digital transformation. That's where in the industry where we are chasing and what we are trying to do, in the whole industry right now, on the digital transformation. Of course, the digital transformation is related to, IR4, is part of digital transformation, is part of the IR, Industrial Revolution 4.0 process. Yeah. So, so that is an interesting way of describing the IoT and AI in this part. So we are going to have this, today I'm going to talk about something related to what I call the IoT sensors. What are the sensors that are available for you to measure or for you to capture, in order to realize the whole IoT or AI part. Yeah. So for this part, I will say, that temperature is one of the main ingredients or parameter that usually we need to do, in the industry. Especially you can see when you do welding, you do some fogging of this metal. In the diagram you can see, you want to do some boiling, creating some steam, boiling, and also some pasteurizing, oven. Those things require heat, require temperature. That's why also, I would like to share with you, how, by using AIoT or IoT part, how are you going to collect, data that you can make this one onboard the data to the cloud so that you can do further processing or analytics. So in this temperature, why is very hot? So let's move on to this part. So when you want to measure temperature, what are the things that you think you can use? What are the sensors that you think you can use? What are the sensors that you use to measure temperature?
Sensor. Temperature sensor.
Okay, temperature sensor is a sensor. Yeah, correct. Temperature sensor is a sensor. So of course you can use the thermistor. Thermistor, actually, if you study electronics in the old way, in the old days, thermistor is used to even, to do the inrush current control. So when this current go very high, temperature goes high, so it can block the inrush current, So, but this part, the thermistor is, says the characteristic of this thermistor is basically resistant. So it's resistant change when the temperatures vary. Yeah. So this is how you can use the resistance to measure uh, the temperature of the device or some apparatus that you want to measure. One of them is the one is the second one. Maybe I ask you ad hoc because you know. I ask you so ad hoc. Yeah. Another one is also a temperature sensor, right? Yeah. I know it's a temperature sensor. It's not a temperature sensor.
Then when we go to see doctor one, the one that put into our mouth. Mercury.
They use a mercury. Mercury is also one part of this thing that you can do visual. That one is a visual checking on temperature visual checking using mercury. That one you can't. That one you use the AI. There's no wire that you can connect to it. So the second one will be, of course, the thermocouple. Thermocouple is widely used in most of the industry. The basic fundamental about this thermocouple is a two piece of different metal piece with a different material. So when when you heat up the two material that join together, you tend to have a different electron flowing through on depending on what material that you're using. So it will create a potential difference. This potential difference will allow you to do the measurement. Of course, when you plot a curve, then you know at which temperature, then you have a different potential across or voltage across. That's how this the temperature is measured. The third one will be the RTD. The RTD sensor. RTD sensor is also a kind of a material that you change, when the temperature change. So from there itself, you can know, these are the three main category of sensors that you can actually use to measure in most of the process plant. So, okay. So of course, in terms of when do you want to use a thermistor, or when do you want to use the thermocouple, or when do you want to use RTD? A lot of the time, making use of these sensors, you require to know what kind of temperature range that you want to measure. For example, you want to do a very high temperature thing. Usually thermocouple is one of them. But under thermocouple, there are many different types. So that will actually, you need to choose, which one you want accuracy, you want stability, all kind of criteria that you need to do. But today I'm not going to talk about so much on that part. But generally, how can we tap onto these temperature sensors? We have some of the I/O modules that usually we use. So, like for example, last time we did some experiment on this what you call some satellite module. That kind of module is actually gathering. When you connect to it, it will do the measurement inside. You have this A to D converter, A to D converter. So from there, you digitize it to become a value. Then it appear to you in some communication protocol. This is one way. This is only the one way, but it's the simplest way and easiest way for you to tap onto this data. As you can see down there, you have a different set of modules. The center one is the thermocouple. So with this thing, what can you do? So I just want to highlight one of the temperature sensors that usually being used in most of the industry, especially from the oven, from all the processes, extrusion process, plastic injection, all those things. Last time we see some of the customers using. So those are mainly using the thermocouple. Thermocouple, you can see there's a two, it's a joining part, it's just like wire lah, but then they are weld together. Yeah. So by using this thermocouple, you can you are able to what? Okay. So you usually would take the thermocouple connect to the temperature controller. Yeah, temperature controller is one of the way how you connect to it. Then you can do the reading from there. Yeah. So what happened if let's say, of course, in terms of IoT, we need to connect this one, and then we need to get the data, and then we want to publish to the cloud. All you have to do create a historian. Yeah. So we need some kind of electronics to convert it, digitize it to a communication protocol that we can transmit to the cloud. So in this case, I just want to discuss with you on one of the actual application where when you are in a factory, yeah. So customers or the owner wants you to help to connect the existing temperature point because the equipment is already set up. What happened is that the challenge is usually you face is you are not going to create another set of thermocouple point in each and every of the things. Usually people want you to retrieve whatever data existing in the demand. So what can you do? Of course, one of them is you can tap on using those controllers already gathering all this data. You can gather data from the PLC and so on. This is one way. The second way is very crucial, very quick way is to join the sensors itself. You tap on to feed it to one of the modules or I/O modules or temperature modules that are able to do measurement. So when it comes to this part, usually you have whether or not you can parallel the thing. For example, they already have a temperature controller connected to it. If you want to do what you can do, there's a put in wire thermocouple to tap onto it. So that itself is giving you a lot of problem if let's say you are using the thing wrongly. There's one thing called thermocouple, there's one thing called open channel detection. When you have this open channel detection thing, you are not able to parallel this thing together. Yeah. So you have to use the right equipment. For example, for us, we know we have one of the modules that are able to tap directly to it, and then we can do it. Yeah. That is parallel. What happens if let's say, the parallel is not someone already parallel to it? You cannot keep on putting too much of this parallel together. So you have another scenario where you need to create another so-called temperature measurement point that you have to take out the thing and then you put in the second element of the thermocouple inside together at the same sensing point. So that is also another way, but that way is more expensive, of course. Yeah. So you have this kind of issue, during the what we call. Yeah. So of course, there's one part in the thermocouple. There's something called co-junction compensation. Some of the modules that we use usually that already come with this co-junction temperature compensation. So co-junction temperature compensation is basically offset, the offset the voltage that drop across the thing, because in the thermocouple measurement, actually you have to have 0 degree at the connection point. So co-junction will help you to compensate that, and then you get the accurate reading. This is one part of the measurement in terms of thermocouple. Of course, RTD, thermistor, they have their own way of how you do reading, but we have all these modules to do the reading. So of course, when you come to after sensing this, you are able to gather data. So what can you do? So for in this case, for example, we have if you've gone through some of our session before, you can use our IoT Edge gateway, and also you can use our this 4G router gateway that can fit this robust TCP to it. Or sometime you may have right now we are using the robust RTU to get but what happens if let's say you don't have this robust interface, so you can actually there's some device don't have robust interface. They give you a photo generating UAM, and you can have another different module of photo generating module that allow you to do the measure. Okay. Then after gathering this part, and then you are able to publish to the cloud. Okay. So that is how you can do gathering data, publish to the cloud. So easy, yeah. So the second part, the last one is let's say, how are you going to you want to gather data, you want to do data logging in-house rather than publishing to the cloud. This is another way. So of course, you can use back the same equipment to do that, but you can apply this using the OPC UA to retrieve the data, and then you can use a web API way to retrieve the data. Also, some of them who like to monitor certain equipment, especially some network equipment and so on, probably SNMP is also one of them. So with that thing, I will talk more about that in detail on how can you implement the OPC-UA for that part. I will talk about that in the next coming session. So yeah, it's quite a lengthy one, It's like something like doing a presentation. This is not a usual way that we do live. We always do live in a very, 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 in a very relaxed manner, a natural manner. But today is like giving a presentation like that. Yeah. So after having all this data, usually what you will do is after you go to the cloud, people want data analytics and so on. Yeah. So Daniel, maybe at your side, you have another set of things that you need to cater from a very fundamental. Maybe you can talk about that. Okay.
So after the data reach the cloud, no matter it's sensor data or whatever information, for example, the transaction or some even the conversation in an email. This kind of thing can be a data for the AI. So in order for to train the AI model, we need the data set or the data. Then there are few types of data. So the most common one is so for those who are doing the computer vision. So image is your data. Video, image and video, these two are very common for those who are working on the computer vision side. And then for those who are working on the machine learning, then the numerical data, even some data in string format for the text. And for those who are working on the related to the signal, the audio can be your data, or some signal in different type of format. So,
for example, somebody is the temperature data. So in order to do the AI analytics, we need to understand the data of them. Usually, we need some understand. Sometimes maybe every second, when I have a recording is a different set of data.
Depends on application. If you want the AI to predict something that is also related to time, then you need to test that. If not, then time step is not so.
Usually, process you need to have because the different process you need a different time step.
It depends on your application.
Okay.
So, and I want to ask Mr. Lee, what is the purpose of creating the data set?
Yeah, to create the data set.
Why we need to create the data set?
Because we need the data set. Of course, it's not like that. Create a data set, because we need a data set for AI, we need to fit that to allow the AI engine to train. So we need the AI data set.
Yeah, so this one is the first purpose. So the second purpose is to evaluate the accuracy of your AI model. So during the exhibition, there is one visitor asked me, what is your model accuracy? So at that moment, actually, I don't know how to answer. If I answer 100%, then it seems like I'm lying to him already. If I answer 0%, also cannot. So I think this one depends on your data set. So I told him to measure the accuracy, it's not like today I tell you 99%, then it will forget 99% one. It depends on your data set, which data set you use. So if today I use a very simple data set, just only 10 images inside, then of course my AI can easily recognize everything in the 10 images. Then I can say I get 100% accuracy. So then this 100% accuracy actually is not meaningful at all because you only want it on a very small data set. And then if let's say someone used another data set that is not related to your AI at all, something that totally different that your AI cannot recognize at all, then your accuracy will become 0. So this is very normal. So if let's say, okay. So in order to measure the accuracy of your AI model, you need to prepare a very good data set, and also the size of the data set is very important. So after we collect for example, we talk about we want to do the person detection. So after we collect the image, then the next step before we start to train the AI, we need to divide the data set into 3 parts. So the first part is the training data set. Then the second part is the validation data set. The third part is the test data set. Why we need to divide into 3 parts? So of course the first one is for the AI to learn. Okay, and then the second part, the validation part, is for the AI to validate itself during the training process. So because we cannot keep on train until the end, then you only check how good the AI model already learned. So during the training process, in between we will stop for a while, perform some validation, test. After that, we continue training again. Okay. So that's the purpose of the validation data set. And then after the training process complete, we will go through the test data set to this is the part we measure the accuracy of the AI model. So the training data set, validation data set, and the test data set, they are totally isolated. So you cannot mix them together. If you mix them, then it's considered cheating already. So the result is not accurate anymore. So
of course we want to cheat. You cheat, that means you want an accurate model, but you cheat, that means
if you cheat, that means you put the training data set into your test data set. Something that AI learned before, be able to give you the correct answer when you go through the testing process. So to create these 3 things, there's rules we need to follow. So we also need to decide how many % of your data should be allocated for training, how many % of your data should be allocated for validation, and how many % you can allocate for the test. So for I think around 10 or 20 years ago, people use the rules. I think it's 50% is for training, and then the rest of the 50% is for the validation and testing. Okay. And now it's different already. People will use 70% for training, 20% for validation, 10% for testing.
Why?
So the reason behind is 10 or 20 years ago, your data set is very small. if you have 10,000 image, it's considered a very large data set already. But in today, 1,000 image is very small. We talk about millions. Millions of images that one is considered large. So when your data set size becomes up to millions, then 70% for training, 20% for validation, and 10% for testing is very enough for you to justify your accuracy.
I think in this area, Canon is mainly you are talking more on the vision AI, or is it generic?
It's generic. To create a data set for the training, validation, and testing, the ratio 7:1 is generic form. Which
become a common practice.
Become a new practice.
So for those of you who watch us in this live, if you, let's say you have any comment or anything that you want to share with us, or you want to give us any comment or things that you want to ask, you can also type it in the chat, on the chat side. So you are actually watching the Jom Less Sembang AIoT from me, my name is CCD, and also Kenya. Again, we want to continue that.
So after you have the training, validation, and test data set, the next thing is you need to look at the number of classes in your data set. So if let's say you have 3 classes, so 3 different things in your data set, and then when you create your training data set, you must make sure the sample of each class in the training data set are balanced. You cannot say you put class 1 and class 2 locked in the training data set and then class 3 just equal a little bit. Then it will affect the accuracy of your AI model when you try to detect the class 3 object. So this one you want to avoid the imbalance.
So you said about this one, these are very fundamental and it's valid thing that we have gone through, have gone through. These are the very practical things that we are doing. So in some of our training, we cover some of these areas.
Yes.
So I think in one of the sessions, I think we did saw to show how to judge, using the software tools also you can judge the accuracy of the result and so on. So that is actually covered in some of the training that we offer.
Okay. So actually before you start creating your data set, you will ask how to get the data set. So one of the ways is you can go from the internet. Actually, there's a lot of open source data set. But at the end, does the open source data set suitable for your application or not? So for example, actually recently we are working on one of the projects that is related to the personal protective equipment. So actually there's a lot of open source data set on this thing. But the image are taken from the CCTV, or some of them is from the movie. And our client want to apply this thing on a drone. So the camera view is totally different. So we have tested already, and from the beginning I already not going to work because the camera view is totally different. So one is looking from the sky to the ground, and another one, our open source data set is like how you're looking at me now. So
more or less like CCTV CCTV.
So when this thing happens, you need to collect your own data set. So that's why you also request some sample video from our client. And the next step is we're going to retrain the model using the provided data set. So when we come to here, we will notice actually sometimes it's very hard for us to get some data set, especially from the drone one. If you do have the drone, you cannot collect the data set. And some data set like more confidential one related to some design of the IC chip. This kind of thing, only the manufacturer has access to it. You don't have access. So our software, the AIS, actually allow you to train your own AI model with your own data set without letting other people know what is your data, how your data set looks like. So this is one of the way to our software can help you to protect your data set confidentiality. And then the insufficient data set is also another problem. So for now, we don't have much data on the thing that related to the defect. Usually the defect, for example, in the smart manufacturing, the image that contain defect usually is not easy to obtain compared to the one image with the good sample.
But sometimes it's confidential also.
Yeah.
Customer also don't release that.
Yeah, they don't want to release this.
Unless they do their own AI.
So this one is one of the challenges as well when we want to collect the data set. And then one more is the quality. So the quality of your data set. The next one is more related to the data set that you collect, is it suitable for your application or not? The one we talk about the quality. Also the resolution, the sharpness of your image, whether your image is blurred or very sharp. Sometimes when your image is blurred, definitely you will accept your AI to recognize the object inside.
So this part actually you're covering all the data set, preparation of data set, what are the standard practice and so on. Because this is very, very, very important. Like just now what I've shared is IoT side also. These are the things that if you didn't get it correctly, you get the wrong data, or prepare the wrong data set. At the end of the day, you are actually defeating the whole purpose of objective technology. This is part. So yeah, can you recall some of the things that you?
I think I really cover everything, almost cover everything.
Yeah, a very short one today from us, me and Kenon here sharing with you on the AIoT. Of course, we are working with partners. We are working with system integration partner, some project house. If you have a different set of IoT or AI thing that you would like to explore, how to make use or how to gather some of this data, or in order to optimize a certain thing for your client, or even yourself, if you have that kind of know-how, you want to do it, we can help you to look into that in detail, how we can proceed from there. Of course, over here we have several different AI, especially on the vision side. We have this anomaly thing. We can the kind of procedure or the way on how to capture things. These are all there. So the thing can be very, very fast in order to perform some of this verification of proof of concept. Especially just now we talk about this our AIS, the AI suite. That part actually you are able to train your own data set. If you have a certain thing, you can train on your own. If you watch us in our this last exhibition, in Smart Nation, that conveyor belt that is running on the thing, is trained by one of our engineers. So we use the AIS to train that, and then you are able to achieve how many percent? I think about 98%, something like that.
Yeah.
That one is they don't do so much effort, but they are able to get about 98% accuracy. So yeah, this is a short one from us in the session number 17. Let's let's Sembang AIoT on me and general. So this is the end of our this session. I will see you in the next session. The most important thing is we innovate, we apply, and then we share, and then we trade. These are our things that we are. Okay, I'll see you in the next session. Bye bye.